Hi Niranjan, good morning. Am I audible? Am I audible, Niranjan? Okay. Hello Harsh. Let us wait for another 30 seconds by the time other students get in. Hi Satish, hi Ranjit, hi Shiva, hi Hitesh, hi Vishnu, hi Ashish, hi John, hi Murli, hi Bindu. Let us wait for some time by the time other students get in. Hi Manjit, good morning. I'm audible, right? Hi Bala. Thank you Harsh. Our in the same time, it will be great if you can suggest me something if you want in addition. Hi Rishikesh, hi Punit, hi Ashish. Let's just wait for some time because I don't want any of my students to miss the class. Though you can get it back the recording from our website. Great Siva, nice to know. Okay, shall I start? Well, before I start the class, I would just like to remind you few things which we have already covered. Like basically we started with the physical India, then we started with solar system. First we have gone for solar system, then physical India, then we have discussed about lithosphere, hydrosphere and atmosphere. Then we have discussed on the river system of India, right? And then the world geography. In the same time we have also covered the global warming part. Today what I'm going to teach is it will be all about earth crust. Earth's crust. Here this is again an important aspect to understand basically the earth, the surrounding on which we are living in. Right? So here what you have to understand is the structure of earth. What we are going to basically study is the structure of the earth. Here, in order to understand the geography of the external landforms, basically when we talk about the structure of earth, we are going to basically learn about the structure that is basically the external as well as the internal. That is, in order to understand the geography of the external landform, specifically if we want to understand the geography of the external landform of the earth, it is essential that we have some idea of what lies within the earth crust, right? So to understand the external part of a body, it is also very obvious to understand the internal aspects of that body, right? So it is not possible to know exactly how the earth was formed, though it is only a mere observation that no billions years ago galaxies were formed, and then millions and billions years ago there was a galaxy formation. In that galaxy formation, sun was at a distance of 33,000 light years from the nucleus, and around the sun earth was evolved. But exactly there is no such a theory which have given a clear cut understanding and a clear cut analogy when the earth was basically formed. Though it is estimated and it is on the probability and on the calculation, that is all ideal calculation, it shows that earth was formed somewhere near 4500 millions years million years ago. Now again, it is not an exact year, it is only an expected year, which is expected that no 4500 million years ago this was formed. Now to understand this, let me go into more into detail, that is now this how they have assumed that 4500 million years ago. The criteria they have taken to understand that this have the earth crust or the earth have been born 45 million years ago was from the evidence of volcanic eruptions, earthquake, waves, deep mine operations, as well as the crustal borings. Crustal borings. By these observations, the geologists have estimated that Earth was formed 4500 million years ago. Clear? So this is just a gist. Now coming back, let me take the Earth. See, this is the Earth. Now, how the Earth basically looks like is something this. These are nothing but you can say the hills. Right? So this is the Earth. Have patience by the time I draw the diagram. If you are if you are taking notes along with me, better you do along with me so that it will be a clear understanding on the fact. Now, so this is Earth. I'll make one more layer. Here, what we see over here, this part is atmosphere. This is Earth. So basically, these two parts are nothing but the crust, the top layer of this. You can see there is a depression as well as there is a elevation, but both are nothing but on the surface. This is the outer surface of the Earth. So irrespective of the elevation and depression, we call the outer surface as crust. Here if you see crust, the elevated part, this is nothing but the lithosphere, right? This is earth crust, right? And this is nothing but lithosphere, which we have already discussed in our previous classes. Here the elevated part is called as, can you name what is this? It is nothing but lithosphere only, but with elevated lithosphere, or example like it can be mountains, right? Mountains. So in simple, it is nothing but lithosphere itself, whereas this part, the depressed part, this one, which have no elevation, those are nothing but those are oceans, that is hydrosphere. So I'll just color that. So if you see this, this is your hydrosphere. So these are all hydrosphere, oceans. Then comes the middle layer. This is called as mantle, and the inner part, that is called as core. Clear? Is that clear to all? If you are making a note, make along with me. Okay, here Harshav asked how from these factors the estimation was done. This was basically from the, basically what they do is, when we take out the soils, what happen? No, when you do a mining underneath the ground, we get fossils, right? So the age of fossils are calculated, and based on that expectation, geologists calculate further. That is much deeper to understand, but we are not going that deep. We are into just a overall that is required as a geologist, right? But what they, how they calculate is by the dating, what they call is carbon dating. That is also one way from where they calculate the ages. So in the similar manner, they also calculate the other aspects of earth, and that is how they have come to a conclusion to 4500 years. As I told, it is not a guaranteed answer that earth was formed 4500 million years ago. It is just an estimated from those particular aspects by the experimentations. It is not a 100% confirmation that earth was formed 4500 million years ago, right? So anyway, as I have discussed, earth, it is composed of crust, mantle and core, and as I have shown in the diagram, I'll go further with individual parts. So I'll start first with crust, right? So before this, no doubt in this, so we have three things, that is crust, mantle, as well as core, right? So it is very clear the earth is made up of several concentric layers, whereas the outer layer of the earth crust, that is lithosphere, which comprises two distinct parts. So coming to crust, that is the outermost, that is lithosphere, it comprises of two distinct parts, the upper part as well as the lower part. It have a upper part as well as a lower part. So the upper part consists of granite. This consists of granite rocks, you can say granite or granite rocks, whereas the lower part, you can call it as basaltic rocks. Here the upper part, which is a granite rocks, it is a composition of, silica and alumina. It is a composition of silica and alumina, so it is also called as Si. I'll change the color. SiAl, that is Sial. Si stands for silica, Al stands for alumina. Similarly, when you go to lower part is a composition of iron and magnesium. Iron, silica and magnesium. So like this is silica, iron and magnesium. So this is in short called as SiMa. So the upper part is a composition of SiAl, whereas lower part is SiMa. This is a composition of silica, aluminium, whereas this is a composition of silica, iron as well as magnesium. Right? Here, this is more denser. When you compare to the density of upper part is density of the upper part is 2.7, whereas density of the lower part is 3. Density is nothing but the mass occupied by a body for that particular volume. So this is nothing but this is called as density. Okay, so density is mass per unit volume. It means what? What density really means is, see here, density is mass per unit volume. What it means? In one volume, how much mass a body occupies is density. So when density is high, it means what? When density high, mass is high. So mass is high means density is high, which because density is directly proportional to mass, or you can say indirectly proportional to volume. So it is very clear. So how it exactly looks is, if I make the diagram, if I have to show it in pictorial form, how I can show this is, say this is the land, say this is the land. Okay, now this land, this is the lower land, lower part. I'm making the lithosphere. It is a land, ground on which we can stand. So this is the lithosphere part, which have two part already discussed. So this is the lower part. I'll write it better. I should write it here. This is the lower part, whereas this is the high part. So, and these are oceans, let us say. Correct? So, as I have told, upper part, so what it is? This is SiAl, that is silica and aluminum composition, that is the upper part, right? Whereas, which have a density of how much? Density of 2.7. Whereas the lower part, it is called as Sima, right? And this density, how much density it have? 3, right? Whereas underneath, this is again, this part is nothing but mantle. Below this, we can say it upper mantle. So anyway, like this is earth, already you have discussed, this is crust, then below this is what? Mantle, right? So this is that mantle. So anyway, when I'll talk to mantle, I'll come to that. As of now, stick with the lithosphere, that is the crust, which is also known as the surface of the earth. I hope this is clear, right? Now, getting back into this, now immediately after this crust, what we get? You have seen, after this crust, what is the next? The next is mantle. So we will discuss on mantle now. Okay, so we have done with crust. Now we'll go for mantle. So the next one is mantle, right? Here in mantle, this mantle is what? Just beneath crust. Here what we have to understand is mantle is also called as, the other name of mantle is also mesosphere. Mesosphere. And it should not be confused with the atmosphere, mesosphere, that is different and this is different. But only the other name of mantle is called as mesosphere, and this is 1800 miles thick. You can imagine, because 1 mile is equal to how much? 1.6 kilometer. So you can imagine how thick this part is. It means if this is the crust, this is the mantle, then this thickness, this T, is nothing but 1800 miles, right? So this is 1800 miles and is basically composed of very dense rocks. It is composed of very dense rocks, which are rich in olivine. Okay. Apart from this, the interior layer, then this was all about mantle, right? So then the interior part, the inside part, what is that? That is called as core. So put the heading, next heading, that is core. This core, the other name of core is also barysphere. Barysphere, and this is 2160 miles in radius. Means this particular core, if I take it, say this is the core, then this radius is 2160 miles, where 1 mile is nothing but 1.6 kilometer, right? And this basically is made up of, iron, nickel, as well as some other components, but this have the maximum composition, and that is why this core is also called as knife. Ni stands for nickel, Fe stands for iron, right? So this is also called as knife. So what we have understood in crust is a composition of crust are two types, one is lower type and higher type. The higher type, or the upper part, is a composition of silica and magnesium, whereas the silica as well as alumina, whereas the lower part is a composition of silica, iron, as well as magnesium. Then coming to mantle, it is a composition of olivine. Then coming back to core again, it is a composition of iron as well as nickel. I hope this is clear to all. And here the important thing to keep in mind as well, that this core is the hottest part, and it is also expected that it can even melt. How? Because this core is estimated temperature as high as 3500 degree Fahrenheit. This is the estimated temperature. Again, it is not a correct temperature, it is only a expected temperature, but at expected temperature you can see it is 3500 degree Fahrenheit. And obviously how it is expected is because of this this core is subjected to extremely high pressure, extremely high pressure, right? Extremely high pressure, and under this condition, under such conditions, the core can be expected to be in a liquid states. Correct or not? Why? The reason is quite obvious. High pressure, correct? High temperature. And what it makes? High pressure and high temperature. Because of high pressure and high temperature, we can expect the core to be not solid, but either it is a semi solid or it is in liquid form, and that is why it comes out as a volcanic lava when it bursts, right or not? So that is how we go across, and that is the reason that in recent studies through earthquake waves, and earthquake wave have suggested that the innermost part, that is the core, this part, the innermost part of the core is probably a crystalline. This is either a crystalline or a solid mass, though it is not yet confirmed. Again, this is only from the estimation from the pressure and temperature that is observed by the geologist, right? So the parts of Earth's crust are immersed by oceans and sea. So this you can see, so this was all about the crust, and this part, the crust part, you can see this is what? The surface, it is immersed with oceans. These are what? Oceans, right? So the earth crust are immersed by oceans and seas, and this form the hydrosphere. This is nothing but, this is hydrosphere, right? And extending and then beyond the lithosphere, this is what? This is atmosphere. And wherever the hydrosphere, the lithosphere as well as the atmosphere meet together, this part is called as biosphere, where the living organisms like us can survive, right? Because for us, what is required? Land is required, water is required, air is required. We cannot survive without air, we cannot survive without water, and we cannot live without land. So it is very clear, for a living organism to live in, the composition of all three is required. I hope this is clear to all. So till now we were talking about the basics, a very basic on earth crust, and we will move further in this. Clear? So before I move in, let me check if someone have any answer. Saswat have asked me one question. What is olivine? Olivine is a material, Shashwat, like iron is a material, magnesium is a material, olivine is also one of a material. Okay. Next question is asked. Michael have asked me, is this Anil sir doing teaching? No, Anil sir is not taking the class. This is Amit here who is taking the class. Next question coming to Hers have asked a question. How from this factor the estimation was done? See, this is all geological factor. There are a lot of things. Are estimated. One is carbon dating. The help is taken from carbon dating. The help is taken from the carbon age. The help is also taken from the atmospheric pressure. The help is also taken from the different temperature formation throughout the year. So combination of all this, the geologists who are studying this throughout their life, they basically estimate that what is the period when this earth was created and how much temperature it is estimated. Obviously what I am talking is, this is all estimated. It is not 100% that yes, the core is going to be with 3500 degree Fahrenheit only. There is a variation, there may be a variation. This is all about the estimation of geologist. I am not the right person to comment on further on this. Coming back to Himanshu's question, Himanshu have asked, sir, every railway station is mentioned with a sea level height. So it's from hydrosphere value? Yes, it is from lithosphere value, Himanshu. It is not from hydrosphere. Already I have discussed this in the last class. What was that? I'll make it. What is sea level? Anyway, I have discussed this many a time, but still I'll say this. Say for example, this is a lithosphere. this is mountain, right? And these are the small hills, okay? And this is, say, sea. So what we take is, we understand this layer, that is top layer of this ocean, as mean sea level. From here, say this is a mountain, and say this mountain is Mount Everest. From here, when we measure this height, measure height is called, this measure height, say the height is 8848 meter. So we say this 884 meter is with respect to MSL. So similarly, say for example, here there is a land. Okay, this is a land and there are homes. So this you can see the height, say it is 1252 meter, say that. So we say this place is at 1252 meter from MSL, and say if this is Bangalore, though I don't remember the exact height of Bangalore, but assume the height of Bangalore is 1252 from the mean sea level. So we say then Bangalore is at 1252 meter from mean sea level. I guess Himanshu, it is understood now, right? Is it understood now? Okay, great. And Michael, I'm Amit, not Anil sir. Fine. Okay. Any other questions before I move into the next part? Any other questions? Okay, great. I hope this is understood what I have taught so far. So I'll move to the next part. That is classification of rocks. Why we are talking about the classification of rock? Because the earth crust, we have seen, this is nothing but composed of rocks, right or not? So next part we are going to talk on the crust mental part of the earth. So then we go for the classification of rocks, and whenever we go for the classification of earth, we know the earth crust is made up of various types of rocks. Already I have discussed that it is composed of silica, it is composed of alumina, it is composed of iron, it is composed of magnesium, right, as well as olivine and so on. So we know it is made up of various types of rocks differing from one another in texture. And what it is, because all rocks, all different type of rocks are different on the basis of texture, structure, color of color, permeability, mode of occurrence, color. Oh, just one second, my pen tab got hanged. Color, okay, color, then what, permeability, right? Oh, one second. Color, permeability, mode of occurrence, and degree of resistance and degree of resistance to denunciation. What it means, if you have to take two rocks, say classification rocks, which I'm going to discuss. Basically, when we are going to classification rock, there are types of rocks like igneous rock, metamorphic rock, and sedimentary rocks, which I'll be discussing in detail. But how these rocks are classified? These rocks are classified based on the texture, based on the structure. I'm sure you know what is texture, what is structure, based on the color as well, based on the permeability. Now, what is permeability? Say this is a board I have taken and I have put all sands over here. All sands over here. So, if you can see, these are the gaps. From this gap, say for example, I'll take this way. Say for example, this was the top view and this is the side view. Here the gap from where air can aspire. Air can be aspired, though we may not see from our naked eyes, but the holes may be very tiny from where the air can actually pass. So that is nothing but that is called permeability. Similarly, rocks can be also classified based on the occurrence, when rocks have occurred, the young rocks, the old rocks. How to understand the young rocks? When the solid and silts meet together, and recently the new rock form is called as young rocks, whereas the rocks which have been for long time, so those are the old rocks. So that is how the mode of occurrence also, through the mode of occurrence also we can classify the rocks, whether it is igneous rock or whether it is a sedimentary rock or it is a metamorphic rock, which I am going to discuss in detail. Similarly, with the degree of resistance, how much degree a rock resists, from that also we can discuss to the denunciation. Denunciation is nothing but the force with which the water flows, bringing soils and silts as well as small stones together as well as pebbles together. So when the rocks and the silts is flown by the water, and when it hits the rocks, few rocks marks starts to appear and few rocks does not show any resistance. Few rocks show the resistance and few rock fails. So that is nothing but that is the degree of resistance. So if question is asked that out of the following which classify the rocks, so this should be the answer. I hope this is clear to all, right? So apart from this, a knowledge of these rocks is also of paramount importance to geologists, because who study the composition and physical history of the earth, basically whosoever study the physical of earth, they need a basic knowledge of the common rocks and the relationship, because the common rocks and the relationship also helps for the geologist to come to a conclusion that when earth was made and what is the composition and up to what is the life of earth as well, and up to some extent the type of natural vegetation and land use also can be studied on the, that is, even it helps in the study of natural vegetation. How? Let me take an example of peat or coal. How it happens? Like say for example, there was a land, there was a tree. There was a tree. Now what happened after some time, say because of cyclone or something, this wood have got dissolved. This is wood. It got dissolved in soil. Similarly, many woods. This was one tree. Similarly, say many trees have combined together, have mixed with the soil. So what happened? After they are mixed together with the soil, after many years, they becomes what? They become fossil. In the name of either coal, they are either named coal or peat based on the composition as well as the calorific value. I hope this is clear to all. So the classification of rocks, I can classify the rock based on this. I can classify the rocks so based on this I can classify the rocks as igneous rock, sedimentary rocks, as well as metamorphic rocks, right? Here igneous rocks can again further be classified as, I'll be talking in detail, but let me first classify this. So igneous rocks further can be classified as plutonic rocks and volcanic rocks. Whereas sedimentary rocks can be classified as mechanically formed sedimentary rocks, that is mechanically formed sedimentary rocks, organically formed sedimentary rocks, as well as chemically formed sedimentary rocks. Similarly, when we go to metamorphic rocks are basically one type, so we don't classify. I'll be talking more detail on this when I come to this particular point. So first, let me start with igneous rocks. So first I'll start igneous rocks. Here igneous rocks are formed by the cooling as well as cooling and solidification of molten rock. Solidification of molten rock. What is this molten rock? I have just discussed few time ago that the lava which comes out, what happen? It will be coming out in the form of molten liquid, and then it solidifies. So that cooling and solidification is nothing but that cooling and solidification of the rock itself is called as igneous rocks. And from beneath the earth crust, obviously the lava which comes from the earth crust, and they are normally crystalline. They are normally crystalline in structure, and they do not occur in strata. They do not occur in strata. That is, strata means layers. So they never and they do not occur in strata, right? As well as they contain fossils because it comes in the form of lava. So they contain fossils and may be subdivided based on mineral compositions. That is again a very vast study, but we will be not going into that particular because we are not a geologist here. So it may be divided on the basis of minerals as well, that is mineral composition. And they contain, basically how it is these are the molten metals which are coming out from the earth inner surface. Here if they contain high proportion of silica, then they are said to be acid in nature. The rocks will be assumed to be acid in nature if they have high proportion of silica, right? How? Because they are composed of what? As you know, igneous rock, there should be like silica, aluminium, iron, magnesium, right? But if this composition is high, then it is going to be acid, and it is hence called as acid igneous rocks. So this, if this acid nature, if the rock is an acid nature, then we call this as acid igneous rocks, right? And such as, and for example, and which are the example for this? Granite are the example, right? So granite are example for this, which are less dense, as which are less denser, that is density is less, as well as they are light in color. Clear? This comparison is with respect to the basic rocks. So those are the few symptoms from where you can identify whether it is a acid rock, that is graphite or not. Granite. So granite is nothing but example of a acid igneous rock, right? So this contain basically a greater proportion of basic oxide, like this compose of like composition. What other composition this will have is like it may have iron, aluminium, magnesium, because already it have silica, right? But silica is in higher concentration, correct or not? So that is how it is. And this igneous rock, so these are the few basics of igneous rocks, and hence these are divided into two parts that are already have discussed. What are those two parts? Those are plutonic rocks and volcanic rocks. Here in plutonic rocks, these are basically, these are the igneous rocks which are formed at some depth in the earth crust, at some depth. The point to be noted is at some depth, and they have cooled and solidified slowly, so that large easily recognized crystals have been able to form. And this intrusive rock, and this rock such as granite, example you can take it as granite, diorite and gabbro, those are few examples of plutonic rocks. So these are exposed at the surface by the process of either erosion or by denunciation. So plutonic rocks are formed at some depth, and they have cooled and solidified. Obviously how igneous rocks are formed is by cooling and solidification. But only thing is they get exposed. This get exposed by either by soil erosion, they get exposed either by soil erosion or by denunciation. I have already discussed what is denunciation. That is when a river flows, what happens? It carries away many parts. Say for example, there is a rock, and that rock, over that rock there is a silt, a thickness of soil. Now suddenly if the water comes through that, what will happen? It will wash away the soil. When it washes away the soil, what will happen? The rock inside that soil will be exposed. So that particular process is nothing but that is one of the denunciation process, right? So that is what is about plutonic rocks. Similarly, volcanic rocks are nothing but the same molten rocks which are poured out of volcanoes as lavas. So basically these are the rocks which are poured, better I should write it since you are making a note. So these are basically molten rocks poured out of volcanoes as lavas, right? And they solidify rapidly on the earth's surface, and the crystals are small. Here, how to differentiate between a volcanic rock and igneous rock is, here the crystalline formation are small, right? So that is what, for example, what are the kind of rocks here? The examples are basalt. So you can see here in plutonic rocks, examples are granite, diorite, gabbro also, we call also gabbro. Here in case of volcanic rocks, example we can take it as basalt, because it is a common volcanic rock and forms lava flows, right or not? Here, like those example, which are the places which place this is there, which these are there, we can find this in North Ireland. These particular rocks are found in North Ireland. The Deccan Plateau in India, it is in Deccan Plateau, correct? As well as Snake Plateau in USA, that is America, right? So these are the some kinds of basalt which solidify in a very peculiar manner to form a long polygonal columns. If say this volcanic rocks basalt, if it solidify in a very peculiar manner, say this basalt solidifies in a very peculiar manner, then further for long time basalt, if keeps on solidifying, then after long time this same basalt will be called as polygonal columns, right? So once a question have also come from here, and well-known examples are those particular places, those are available in this particular places, right? I hope this is understood. So here what a basic understanding or common moral we can take it from about the igneous rocks are, basically these igneous rocks are extremely hard and resistance. For this reason they are required for road making. So if you see the road making, how they make the road, before they put in the tire, before the coal tar, they put those rocks. So igneous rocks are generally extremely hard. Let me decrease the size of the pen. These are extremely hard, as well as they have good resistance. So we can say these are hard and resistant rocks. Clear? I hope it is clear about igneous rocks, right? Okay. Before I move in to the next part, let me check few questions. Michael have asked what is olivine. Olivine is nothing but olivine is a mineral in itself. That is, olivine basically, as I told, it is a mineral. It is a magnesium, iron and silicate. It is it's a composition. It is a mineral in itself which is composed of magnesium, iron and silicate. Already I have discussed this. Olivium, anyway I should write it, you are asking again and again. Olivium, it is basically a mineral which is a composition of iron, aluminium and magnesium. I hope this is clear now, Michael. Clear? Okay, let me move to the next question. What is the next question? How to figure out that the life of earth is? Say, this is what the geologists are meant for. Okay, they take very different aspect. There is no such one formula. There is no such one formula, one calculation from where this is figured out. This is only assumptions which they are making from different processes, including carbon dating and different high level instruments, including satellites, including atom, CERN, that is CERN on atomic levels. That is how it is. Physicists, geologists all together are working on the same. There is no such particular theory which clearly says Earth was formed this particular time back. Okay. So you should not get confused. What is the difference between coal and peat? The difference between coal and peat is with respect to the calorific value. The calorific value are different. Peat are nothing but peat. Say for example, peat are the youngest coal. You can say peat are the youngest coal, whereas coal, if you have to compare coal and peat, you can just say peat are the youngest coal. Both are formed by the formation of woods. What happened? The wood that get decomposed year after year, year after year, year after year. So after million years ago, after million years, that particular wood, what happened? When they get intact with a lot of pressure and temperature, they formed as a pit and a coal. Pit and coal, how we differentiate is with respect to the calorific value. Okay, the calorific value of both the things are different, and that is how we differentiate between coal and peat. Coming back to the next question, restrictions on mineral composition of igneous rocks. See, there is nothing like restriction on mineral composition. It is what happen is, it is a composition of what earth is made up of. Why it is made up of? There is no such answer as of now, but if I get it, I'll definitely get back to you on this. Clear? Now, Priya have asked me a question. Igneous rock do not contain fossil. It contains, but a very less, in fact, very less compared to any other parts. They have fossils as well, but very less, almost negligible, right? Okay, coming to the next part. So I hope igneous rock is clear to all. Now I'll come to the sedimentary rocks. Fine. Okay, next. Sedimentary rocks. Here, sedimentary rocks are basically formed by the sediments. Sediments accumulated over a long period of sediments. Those have been accumulated over long periods. What was the case of igneous? In igneous, the lava which comes out, the molten which comes out and cools down, after cooling down, the rocks which are formed are called as igneous rocks. Whereas in case of the accumulation of sediments, if it forms a rock, and that particular rock is called as sedimentary rock. And you know, the best thing and a very good thing to understand over here, these rocks have a cycle. Means a rock first becomes igneous, then becomes sedimentary, then becomes metamorphic, and finally again this metamorphic breaks down into igneous, and this cycle of rocks continues. So here sedimentary rocks are the sediments accumulated over long periods, usually underwater. Basically usually under water. Here what to be understood from here is underwater, and how we are going to distinguish this is, they are distinguished from the other rock types by the layer formation and the terms as stratified rocks. They are actually also termed as stratified rocks. That is how they are distinguished by the other rocks from the stratified rocks. Strata means nothing but the layers, and the strata may vary in thickness from few inches to few feet. Basically the strata is nothing but the layer, it may vary from few inches to few feet. So there should not be any confusion on this. And these rocks may be coarse, may be fine grained, may be soft, or it may be hard as well. There is nothing like sedimentary rocks only have to be coarse or fine grained or soft or hard. It can be anything out of four, or it can be a combination of all, right? So the material that forms sedimentary rocks may be brought by streams, since as we have discussed, this sediment accumulated. So these are nothing but, this can be bring by streams, glaciers, winds, or even animals. Even animals. It can be anything. What happened? This is an accumulation. This is not one day job. It is not a one day process. It takes a long period to form sedimentary rocks. A small sediments together becomes a sedimentary rocks, right? And even they are not none in crystalline. They are non crystalline. They are not crystalline as igneous rock. So the main difference over here, another one more difference apart from this, is they are non crystalline and often contains fossil, often contain fossils of animals, plants, and other organism. If I go back to the question of Priya, she have asked, igneous rocks do not contain fossil. They do not contain. If they contain also, they will be very less. Whereas sedimentary rock contains fossils, and those fossils of animal, plants, and other organisms, right? Clear? So sedimentary rocks are thus most varied in the formation of all rocks, and sedimentary rocks are classified according to their age and different kinds of rocks. Basically, sedimentary rocks are differentiated based on their age and different kind of rocks. Different kinds of rocks formed during the same period. Okay, it is also more useful to know the characteristics of various kinds of rocks, and hence sedimentary rocks may be classified under three major categories, which already I have described above. That is mechanically, that is how it can be described in three other forms: mechanically formed sedimentary rocks, organically formed sedimentary rocks, and chemically formed sedimentary rocks. So I will discuss in detail of this. So those are the basics of sedimentary rocks, right? Now coming back to the types, classification and types. Here sedimentary rocks, the first one is mechanically formed sedimentary rocks. Here the mechanical formed sedimentary rocks, these are basically formed from the accumulation of materials. These are basically formed, I should rather, instead of doing this, let me put in the classification so that it becomes easy. There are three types, so basically let me take it. So first one, mechanically formed sedimentary rocks. Second is organically formed sedimentary, and third is chemically formed sedimentary rocks. Sedimentary rocks. Okay, so the first one, coming to the first one, let me discuss the first one first. So basically these are formed from the accumulation of materials derived from other rocks, derived from other rocks which have been cemented, together, which have been cemented together, right? Just make little fast if you are making a note, but in the same time understand this. Here basically this is the accumulation of materials which are derived from other rocks which have been cemented together, right? Now for example, which are the examples? Sandstones are one example of this, which are probably the most familiar sedimentary rocks because they are made from sand grains. They are basically made from sand grains and often quartzed, and often quartz fragments derived from granite, which are derived from granites. Okay, their texture, composition and color vary tremendously, as well as many types of sandstones have been quarried for building purposes or for making grindstones. A coarser type of sandstone is also called, like no, the sandstone, if you take the coarser type is also called as grit. The sandstone which is of coarser shape, a coarser type, is also called as grit. When larger pebbles are firmly cemented to form a rock, that is called as conglomerate. When pebbles are rounded, or breccia when the fragments are, this is the larger, like it was one sandstone, one second, okay, sandstone, this was sandstone. Similarly conglomerate, basically these are found when larger pebbles are firmly cemented. Uh, Firmly cemented. Similarly, when the pebbles are round, they are called as breccia. Breccia. These are when pebbles are round, right? these are rounded, sorry, these are angular, pebbles are angular. Just pardon, there is a problem with the pen tab, let me correct it. Here this is when pebbles are round. Whereas here when the pebbles are angular. Okay, so this was all about the mechanically formed sedimentary rocks, right? I hope this is clear. Similarly, coming to the second part, that is organically formed sedimentary rocks. Here basically these are formed from the living organism. If you see, earlier mechanically it was an accumulation of materials which we have cemented together, but when it comes to organically formed, basically they are formed from the remains of living organisms, such as corals or shellfish. This is also called as shellfish, whose fleshly parts have been decomposed after the decomposition of their fleshly part. Clear? And thus leaving the hard cells apart. The most common rocks here are the calcareous types, which include limestone and chalk. Example of this kind of rock is, here example you can take it as sandstone, whereas example here you can take it as limestone, chalk. Those are the few examples you can take for organically formed sedimentary rocks. Even the carbonaceous rocks are also organically formed, but from vegetative matter, that is swamps and forest. So the pressure of overlying sediments has compressed the plant remains into compact masses of carbon, which eventually became peat, lignite or coal. Basically what it is, what I am trying to tell is, the carbonaceous rocks, even the carbonaceous rocks, examples of carbonaceous rocks, carbonaceous of what happened to the pen tab? Okay, carbonaceous rock example we can take are peat, lignite or coal. Even lignite is one type of coal, so you can take peat or coal, right? So those are nothing but, and these have a greater economic values, right? So this we find basically in organically formed sedimentary rocks. Similarly, chemically formed are nothing but the precipitated chemically formed solutions of one kind or another, because of chemical compositions. The rocks formed because of chemical compositions are nothing but chemically formed rocks. Here rock salts are derived from strata, Example here, that is one type of rocks are also called as rock salts. Here we can find rock salts. So question may be asked where rock salts are found. So rock salts are found in sedimentary rocks, which are chemically formed sedimentary rocks, that is rock salts. So rock salts are derived from the strata. Strata means the layers, which once formed the bed of seas or lakes, right? Example here you can take it as gypsum, gypsum or calcium. This you can also call as calcium sulfate, right, which is obtained from the evaporation of salt lakes such as Dead Sea, which have a very high salinity, right? In similar ways, potash and nitrous may be formed, correct? So those were basically the classification of sedimentary rocks, right? I hope I'm clear. Now I'll go to the last one. So we have covered sedimentary rocks as well, that is all the three: mechanically formed, organically formed and chemically formed. Now I'll move to the third part, that is metamorphic rocks. So the third type of rocks after igneous and sedimentary is metamorphic rocks, right? So this is all rocks, whether igneous or sedimentary, may become metamorphic. It's not necessary that it have to come from a different origin. So any rock which are igneous or sedimentary may form metamorphic or changed rocks under great heat and pressure. So these are basically formed under great heat and pressure. Here their original character and appearance may be greatly altered by such forces, particularly during intense earth movements, right? In this manner, clay may be metamorphized into slate. Even at this great heat and pressure, even clay can form slate. Similarly, if limestone is under great heat and pressure, limestone may form marble. Similarly, sandstone into quartz, correct or not? And the same way, granite, if high heat and pressure is given, even that may form to gneiss, whereas shale into schist and coal into graphite, correct? So if you see the pencil tip graphite, that is nothing but a high carbon, that is nothing, a coal, if it is given a high heat and pressure together, that converts to graphite. So basically those are nothing but those are the rocks. So those are the kind of rocks. So if how it happens is, first it is igneous rocks, then by denunciation and accumulation it becomes sedimentary rock, and then metamorphic. Now what happened? Again this metamorphic with lava, it comes out and again falls on the surface, and again this is nothing but your igneous rocks. So this is nothing but, this is also called as a rock cycle. I hope this is clear to all now, right? So that was all about the basics. Where does limestone fit in? I have already discussed where limestone fit in. Limestone basically fit in the organic, limestones are nothing but they are the organically formed, so they fit in sedimentary rocks. So those are in sedimentary rocks. So limestone metamorphic rock? No, metamorphic rock is not limestone. It is sedimentary rocks. But if limestone is given with huge heat and pressure, then it will form to metamorphic rock, and when limestone form to metamorphic rock, it will be no more known as limestone. It will be known as marble. You can see here I have already discussed, if it is a clay and if you give a heat and pressure, then it will convert to slate. Similarly, if it is a limestone, if you give a heat and pressure, it converts to marble. So here limestone appears in sedimentary part, right? And when you give a heat and pressure, then it converts to quartz. I hope this is clear to all. Clear? Now, so this was all about rocks. So then this is nothing but we are talking about the earth. So earth is obviously composed of this. So even earth have what? Earth, the landform, have mountains as well. So we'll be discussing about the mountains, that are the type of mountain. Those are nothing but like fold mountain, and then you have we have block mountains, then we have volcanic mountain, and so on. But before that, first of all, let us understand how the earth movement and the major landform occurs. Earth movements and the major landforms, right? So here this earth movements and the major landforms, these are nothing but the face of earth is constantly being reshaped. It is never constant. The face of earth is reshaped constantly reshaped by agents of denudation. The word is denudation. 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 That is nothing but, denudation is the running water, rain, frost, sun, wind, glaciers and waves, so that our present landform varies. Because of this, the present landform varies in diverse. Correct or not? Say for example, say this is a mountain, here water is frozen like this. So what happened? It will carry some soils. What will happen? It will start depositing over here, over this corner, right? And that is how it starts forming. So slowly and slowly, some become rocks and some becomes plain as well. So that is how the earth movement and the major landforms actually do occur, apart from earthquake and volcanoes as well. But these agents only modify the pattern of mountains. Basically here this running water, rain, frost, this basically what they do? This basically modify the pattern. Correct or not? Pattern of what? Pattern of mountains. Correct or not? Say this is a mountain. If river will start coming from here instead of there, what will happen? It will eat out the basement of the hill. So the hill will be, after say for example, now again this river will dry up. So how the hill will look like? This will look like this. The hill will look like this if the water dries up. Correct or not? So this is what? So this part is nothing but this is the variation than before, and this variation is because of this either running water, rain, frost, sun, wind, glacier, or waves, or anything else. And this variation in diversion is nothing but this is a new pattern, and this keeps changing. So the phase of, that's why we call the phase of what constantly keeps changing or constantly is reset. That is how it is, right? So there are, apart from this, so when we talk about mountains, again we are going to discuss on mountain. Before this, before we understand this, we have to understand three important things. That is Caledonian, Hercynian, and the third is Alpine. Basically, these are the organic movements. Caledonian is an organic movement, like the movement which happens. We have classified this into three types. Caledonian, these are organic movements. So Caledonian, this was about what it was? Yes, about 320 million years ago. Whereas Hercynian is 240 million years ago. In case of Alpine, it is just 30 million years ago. That is, we are living at present, it is Alpine, right? After this, again it changes to Caledonian, Hercynian, and then Alpine. So young fold mountain, basically in this recent, in Caledonian there were some formation where a mountain had took a different shape. Hercynian, the shape was again different. In Alpine there was again different shape. Basically, when we talk about the recent Alpine, young fold mountains ranges were buckled up and overthrust on a gigantic scale. Being the most recently formed, these ranges such as Alps, then Himalayas, Andes, and Rockies. We have already discussed this when we were discussing the world geography, right? So, but the time will come when this lofty ranges of Alps, Himalaya, and so other hills or mountains, those that even existed before. Basically, what happened? No, these peaks are sometime even several miles high. Correct or not? But the time will come when these lofty ranges will be lowered, like those that existed before. So that is how a time is going to come, but again that is a long thing, that is only a perception as per the geologist. So what we are going to discuss now from here is the formation of mountains and the types of mountains. So here we are going to discuss the mountains. So mountains are basically made up of large proportion of earth's surface, correct or not, based on their mode of formation. So we can classify the same mountains, we can classify as uh, fold mountains, right, then block mountains, and then the third one is volcanic mountains, right. Here, before we move in to this part, let us take a break of 1 minute as asked by the student. So let's go for a break for just 1 minute. Shall we start again? Am I audible? Am I audible? Can someone answer? Okay, fine. I hope you are understanding, right? Any questions? Any suggestions before I proceed? Okay, fine, Murli. So we go to the next part, that is mountains. So when we talk on mountains, those are basically classified into three types, that is fold mountains, block mountains, and volcanic mountains. Fold mountains are basically the mountains which are by far most widespread and also the most important. That is how they actually look like. Say for example, how they go is, say for example, this is a land which have different layers. Say for example, this is a land. Okay, this is a land. Let me just put different colors so that it will be clear for understanding. Now when this goes through compression, because of the tectonic shift or the movement of earth, what happen is, this take a shape of something like this, right? So this was the bottom part, this was the middle part. I have missed the top layer. So this, because of compression, the formation, see this formation, you can see there is a crest as well as there is a trough, that is there is a elevation as well as there is a depression. So such kind of mountains which are formed, those are basically called fold mountains, and in such case the top portion is known as anticline, whereas the bottom part is called as syncline, right? Here these are basically caused by the large scale earth movements when stresses are set up in the earth crust. Such stresses may be due to the increased load. This may be due to the increased load. This is what? This is a some force. There is a tectonic, because of tectonic shifts or because of the movement of the earth, because of the forces in either direction, because of increased forces or increased load of this overlying rocks, what happened? The flow movements in the mantle, magnetic intrusions into the crust, and because of this some part of earth there will be a formation of anticline as well as syncline. This is anticline as well as syncline, right? So the rocks are subjected to compressive forces, the product wrinkling or folding along the line of linkage. Because of this force, there will be what? Wrinkling. This wrinkling. So because of this wrinkling, what happened? The formation of mountains are called as fold mountains. along the line of weakness. Wherever the line is weak, obviously what will happen? The fold will be more, right? So the up folded waves are called as anticlines, whereas the throws or the down fold, these are also called as throws, whereas this is also called as crest. So syncline are also called as throws, whereas anticlines are called as crest, that is CREST, right? Basically, in the great fold mountains of the world, such as the Himalayas, Rockies, Andes, Alps, due to the complexity of compressional forces, the folds develops much more complicated forms when the crest of a fold is pushed too far. When this crest is fold too far, it goes on for too far, right? An overfold is formed because of, if it is continuously, say for example, the folds, if the crest of the fold too far, say for example, if it is pushed too far, what will happen is it will overlap with one another. So when it overlap with one another, then this overriding portion, these are nothing but those are hills, mountains, sorry, those are mountains. But what happened now, when the crest of the fold, this crest is pushed too far, when this is pushed too far, what happens is the overfold is formed. This is the overfold. This overfold is formed, and if it is pushed still further, then what happens? It becomes a recumbent fold, and finally the overriding portion, you can see this has overridden this, so this portion is called as nap. Clear? And fold mountains, and this fold mountains can be mountains of, this also called as the mountains of elevation. So the mountains, the fold mountains are also closely associated with volcanic activity, but not exactly, but they are also closely associated with volcanic activities. They contain many active volcanoes as well, especially in circum-Pacific fold mountains, and basically in circum-Pacific fold mountains. What are the examples? What is the important thing to understand and remember over here is, they are also rich, this particular kind of mountains, that is fold mountains, they are specially rich in tin, copper, gold, as well as petroleum, right? So those are the few important things to understand when this discussion of fold mountains come into picture, right?